In this lesson, we're going to learn how to factor polynomials with 4 or more terms. So the key to factoring by grouping is to factor out a greatest common factor. So let's go over how to do this with some old examples. So if I look at these 2x and 7yx, the greatest common factor would be an x that's shared by both. So what we always have done is we put the x out front, and then we divide by x, which would result in 2 plus 7y. So it'd be x times a quantity of 2 plus 7y. Well, it doesn't always need to be, something like an x or a variable. What if we had 2 times triangle? Well, 7y triangle. What's my greatest common factor? It's the triangle. If I divide both by triangle, I have triangle times 2 plus 7y, whatever it happens to be. Now, I don't know why you'd ever actually do that, but I think it's helpful to understand where we're headed today. So the greatest common factor could be this triangle, or maybe it's a binomial. So if I look at this, there are two terms here. Here's my first term, and here's my second term. It's held by multiplication, and there's addition in the middle. So what's common to both? Well, this time it's a complete binomial, the x minus 5. So what I'm going to do is divide by x minus 5. I'm going to pull my greatest common factor out to the front, and I'm going to divide each term by the x minus 5. When I do that, the x minus 5 cancels, and I get 2 plus, again the x minus 5's cancel, plus 7y. And I end up with 2 binomials multiplied together. This last one on your screen is really how many of the ones in today's lesson will play out. Just one more before we begin the examples on your paper. So again, take a look at this. What is common? This time it is a binomial factor common to both, a 4x plus 1 in both places. So what I do is I bring that 4x plus 1 out to the front, and I divide each term by 4x plus 1. When I do that, what remains is a 5x in the first term and minus 9 in the second term. So I get these two binomials. So let's do the first example on your note guide in this format. We're at number 13. So I have a polynomial with 4 terms. So what I'm going to do is, first of all, I'm going to try grouping this as 2 terms together and another 2 terms together. So I'm just going to put a set of parentheses like this, and I can't just put parentheses after a minus like that. That would totally change the value of everything in the parentheses. So what I'm going to do is bring back something old here. I'm going to change this to plus a negative. Plus a negative is the same as a minus. Now I can put parentheses here because having an addition sign in between is fine. It doesn't change the value of anything after it. All right, so why do I do that? Well, I'm going to just factor out my GCF multiple times. So I'm only looking at my first binomial, and I have at least an x to the second power in both terms. So I'm going to divide both by x squared, and when I do that, I'm left with x to the first minus 3. I'm going to bring down my plus, and I'm going to look at my second binomial. I have a negative 16 and a 48. So my leading coefficient's negative. Hate when that happens. So I'm going to factor out a negative value. And I believe 16 goes into both 16 and 48. So I'm going to divide both here by negative 16, which gives me positive x minus 3. And now let's observe what we have. The line I'm at now should look an awful lot like the previous 2 we did. We have this addition sign in between, so here's a big term and here's a big term. Do you see anything common? Hopefully that binomial factor is jumping out at you. You see an x minus 3 in both terms. So I'm going to bring the x minus 3 out to the front, and now I'm dividing each term by that x minus 3. When I do that, x minus 3's cancel, and I have an x squared plus negative 16 in the second one, and folks, I hate plus negative 16. I did that for your benefit. I'm never going to write that. I will always write x squared minus 16. Okay, so it's factored. I have a binomial times a binomial, but hopefully you spot my favorite pattern of all time right here, the dots pattern. the difference of two squares, and the difference of two squares would factor into, take the square root of x squared, take the square root of 16. The pattern says one is a plus and the other is a minus, and don't forget to bring down this first, x minus 3. So bottom line is, if I would multiply these three binomials back together, I would get the simplified line that I had started with. All right, so we've just got to practice here. So we're going to begin by attempting to group this as 2 and 2. But again, I can't just put parentheses after a minus, so I make it plus and negative. Okay, so GCF of the first grouped binomial would be an n squared. I'm going to bring that out front and divide both by n squared. When I do that, I get n to the first plus 5. Now in the second binomial, I'm going to factor out a negative 9. So rather than writing plus a negative this time, I'm just writing minus 9. And now I'm dividing each of these by negative 9. That produces positive 1n plus 5. Assess what we have. I spot a common binomial factor of n plus 5. So I'm going to bring that out to the front, and I'm going to divide each of these by that common GCF. And I'm left with an n squared in the first and a minus 9. And again, awesome. I hope you spot again my favorite factoring pattern, which would factor into n plus 3 and n minus 3. And I am going to not forget about the n plus 5 in the beginning. So those three factors would form the cubic polynomial that I started with if I were to multiply them all back together. So just a reminder that this multiplied form is known as our factored form, and what we started with no like terms or parentheses, was our simplified form. Okay, on to the next. Again, let's try grouping as a 2 and a 2. Now, occasionally you might find if your grouping doesn't work, you might have to change the order of your terms, but let's attempt this. So group the first, change this to plus and negative, and group the second. So the first binomial, I believe 25 goes into both 25 and 100, and I have a y squared. So I divide each term by 25y squared, which would produce y to the first minus 4. Now, this second one, if you observe, second binomial here, it's super close to what we have, but I got a negative y plus 4, and these are not like, plus I have this leading coefficient that's negative, and you know I hate that. So what am I going to do? I'm going to factor out a negative 1. So I'm going to put minus 1, and I'm going to divide each of these by negative 1. So this would produce positive y minus 4. Now I've got some matching binomials. I've got this y minus 4 and this y minus 4. So what do? Bring that y minus 4 out to the front, and I divide each by the y minus 4, which would result in 25y squared minus 1. And again, yes, I have my favorite factoring pattern, the dots. 5y plus 1, 5y minus 1, and don't forget about this original GCF. I would like you to try this one on your own. When you're ready to check your answer, hit play. So I hope you began by grouping as a 2 and a 2. This time there's an addition sign, so you were able to just put your parentheses after it. Look for your GCF of the first binomial would be 2r to the second. Now you're going to divide each of these by a 2r squared, which results in r minus 7 plus, now it looks like I have an 8 common to both. Divide by 8 and I get r minus 7. So, do I have anything in common? I sure do. I have r minus 7 and r minus 7. So since that's my common term, I'm going to bring that r minus 7 out to the front. And I'm dividing each term here by r minus 7. Cancels and cancels. And what remains is 2r squared plus 8. every other time I had the dots pattern. This is not the dots pattern. However, I do notice that there is a 2 that's common in this binomial. So I could factor that 2 out to the very front. I would just bring it out to the very front, recopy the r minus 7, and then divide both by the 2. So it'd be r squared plus 4. And r squared plus 4 does not factor further. It would have if it had been a minus, but there's no such thing as the sum of 2 squares. We only have the sum of 2 cubes.